Hello class. Today we're going to review the order of operations for solving any type of mathematical equation. And this should be reviewed for you at this point. But again, let me remind you that you should always make sure that you stay on top of your skills as far as solving problems without a calculator. So that is definitely the way you should approach this section of the material as well. Do not use a calculator when solving these problems. We want to make sure that you still remember the basic rules of math. So with the order of operations, you need to recall the four basic operations of math, all right, and they are listed here for you. We have addition, subtraction, multiplication, and division. And the purpose of this lesson, again, is to make sure that you are still able to do these operations without a calculator. Can't stress that enough. Okay, so let's get started into the review. So first off, you're going to find that in the book you are sometimes asked to solve, sometimes asked to evaluate, and sometimes asked to simplify. You're going to see the word simplify a lot in this particular section of material. So when it says simplify, what does that mean? Well, if we're simplifying anything, that means we're making it easier to understand or breaking it down. And that's exactly what the order of operations does. We're going to take a look at example 1 here, and if we are asked to simplify this very long expression, 36 plus 8 divided by 4 times 2 plus 0 times 8 minus 7 times 5. Whew, that's a mouthful. Okay, but if we use the order of operations to break it down, we can make this much more simple to do and understand. So let's start thinking here. The order of operation exists because problems like this, if you see in the bottom of the slide, if we all started in different places, we would all get different answers. So we need to come to an agreement as far as how the calculations need to be done, and that's what the order of operations is all about. Okay, so let's go into simplify. Simplify again means to rewrite in simplest form, or in other words, do as much as you possibly can, and then stop. So you know you're finished with these problems when there's nothing else to do. So for example, 3 plus 4, that's an easy one, but it simplifies to the value 7. There's nothing else to be done with the 7, so that's how we know to stop. So again, we need the order of operations simply because it gives us an order to follow so that everybody ends up at the same location and we don't get various answers to the same problem. Is there a way to remember the order easily? And hopefully at this point you're saying yes, there is a way to remember the order easily, and it is this. Please excuse my dear Aunt Sally. This is meant to help you remember the order in which to go about solving. The P in please, that's to remind you, always look for parentheses. Excuse, that leads you to exponents. My, multiplication. Dear for division. Aunt for addition. And Sally for subtraction. Okay. So here's the thing. At this point, or up until algebra, all right, 6 separate steps for the order of operations. You would do your parentheses first, then do your exponents, then you do your multiplication, and so on. 6 different steps. In algebra, we like to shorten things a little bit. So for this case here, when we're talking about the order of operations from here on out, and this goes for any math course that you're going to take beyond Algebra 1, we're actually going to condense the 6 steps into 4 steps. Your first step for parentheses, that's going to remain the same. All right? You are going to do anything within parentheses first. And we'll talk about what you do if there's more than one set of parentheses in a few slides. So just hang on to that question if you had it. Exponents is also going to remain a step on its own. You will look for anything with an exponent after you have simplified the parentheses, and then go ahead and simplify the exponent. Here's where we start to sort of smush things together. Multiplication and division can actually be done at the same time. The way you're going to go about this is you're going to look at whichever one happens first in the problem, that's what gets done first for that particular set of operations. So in other words, you're going to look for multiplication and division from left to right in the problem. As soon as you get to a particular multiplying or dividing portion, then you can go ahead and do just that portion. And you'll see this in the examples we're going to do. Addition and subtraction are also very closely related, right? They are opposite or inverse operations of each other, and we're going to handle those the same way as well. You can do them pretty much at the same time. Whichever one happens first gets calculated first. Or in other words, again, from left to right, you will be solving the addition and subtraction. So with algebra, what we've done is we've taken those 6 steps and we've now condensed them down into 4 steps for the order of operations, which will save you a little bit of time as well, and that's always a good thing. Okay, so now that we've gone over it, let's try some of these. Now, I'm not going to have time to go over every one with you, but you should copy all of these examples into your notes and try them. If you need to check answers, just bring them into your teacher and we'll be happy to look over it to make sure that you've done it correctly. Okay, so I'm going to start with the first one. At this point, you can either pause the video and copy all 4 of them down, or make sure you pause it at some point to give yourself time to get all 4 problems copied into your notes. So with example 1, we're starting with the problem 14 plus 12 times 3 plus 2 divided by 2. Again, that's a big mouthful. So we're going to break it down according to the order of operations. So starting with please, in this case, we have no parentheses, so we can skip that step. Next one, excuse, exponents. Again, no exponents. So far, good to go. Now we're going to look for both multiplication and division from left to right. So as I'm going across the first problem here, the first portion I see is a 12 times 3. That's what I'm going to do first. All right, so multiplying 12 times 3, either on scratch paper, because we're not using calculators. All right, I'm going to take my 3 times 2, which gives me a 6, and 3 times 1, which gives me a 3. So I know 12 times 3 is going to give me 36. Continuing on with the problem, I next see a plus sign. I'm going to ignore that because I'm not on the addition step. But I now see a 2 divided by 2. I'm on multiply divide step, so I'm going to go ahead and do 2 divided by 2. Well, that's easy. 1. And now fill in the rest of the problem that you haven't used. So we're left with all addition. This can all be done at one time. Again, from left to right is how you should try to approach this. So the first one that I come across is a 14 plus 36. So again, if you need to do that off the side with scratch work, that's fine. Otherwise, 4 plus 6, that's going to give me a 10. I'm going to carry the 1. 3 plus 1 plus another 1 is going to give me a 5. So 14 plus 36 gives me 50. Now I'm going to consider the rest of the problem that hasn't been used, which is the plus 1, to get our final answer of 51 for the first example. Now I'm going to skip the second and the third, and I'm going to jump down to the fourth example. You can definitely see right away we've got parentheses here. We've actually got 2 sets of parentheses. Start with the first one from left to right. We're given a 1 plus 8 in parentheses, so that's pretty easy to simplify to a 9. Our second set of parentheses, however, is a little more complicated because not only do we have addition in that set, but we have an exponent as well. So you still need to consider the order of operations. Out of the 2 items that are in the parentheses, addition and exponent, we need to simplify exponent first. So doing so, 2 squared gives me a 4. And then I would have a plus 5 still in the parentheses. So let's just rewrite the problem so we're clear on what still needs to be done. We've simplified the first set of parentheses to a 9. I haven't used that minus sign that comes next, so I'm going to bring that down. And we still have a 5 plus 4 in parentheses. So, because there's still parentheses, they need to be done first. 5 plus 4 gives me a 9. I'm going to bring down everything else that hasn't been used in the problem. And now we're left with one simple subtraction. 9 minus 9 gives us an answer of 0. Okay, so as I told you, we would talk about what happens if you have more than one set of parentheses in a problem. And more specifically, I want to review the various types of grouping symbols you may come across. They're all treated the same as parentheses, but we need to make them look differently because in more complicated problems, as you're going to see, we can have 2, 3, 4, sometimes even more than that, all used in a single problem. So we've already covered our basic parentheses. We can also square off the parentheses, and then we call them brackets. The curly type, or almost like a profile of a person's face with a nose sticking out, those are called braces or curly brackets sometimes. You can also have absolute value. We just did absolute value a few lessons ago, so hopefully that's still fresh in your minds. It is a grouping symbol as well as an operation for you to consider the distance that a number is located from 0. And then finally, a division bar or a large fraction bar, that also needs to be treated as a set of parentheses. You're going to need to consider invisible parentheses on the top and bottom of a problem like this. Solve the top and bottom first, then do your division. Okay, so pause the lesson here. That way you can get all of that copied down because you will see each of these throughout your assignments. I'm going to move on to an example using several of them, and we'll try and go through this rather quickly. So what I see here first is a regular set of parentheses inside the set of brackets. And as we just went over in the previous slide, whenever this happens, you want to work from your inside out. So because 17 minus 5 is in the innermost set, we're going to do that first. 17 minus 5 gives me a 12. And again, I'm going to continue with showing my work by writing everything that we haven't used yet. The parentheses are gone, but square brackets are still there, and those are the same as parentheses, so they need to be done next. 36 divided by 12, again, no calculators here. You can either write it out in long division form, which looks like that. Otherwise, you may already be able to decide, well, I know 12 times 3 is 36, so I'm just going to replace that with a 3. Either way. Now we're left with a simple addition problem, definitely no calculators needed here, and we get our final answer of 6. Okay, so let's go on to the next one here, and I already have it started for you just to save some time. Our first set of parentheses we come across, 7 plus 32, that gives us a 39, and again I rewrote the rest of the problem. Continuing on, first thing that comes in our square brackets, 3 times 39 gives us 117. Now we're going to divide that by -8. That's going to give us our -14.625. And last thing, add your positive 12 to it, and that's going to give you a -2.625. Again, you can use scratch work to work this out because you shouldn't be using a calculator if at all possible. Okay, so the last one here, I'm going to leave this for you to try. You should copy it down into your notes, follow the order of operations as we've discussed, and then bring it into class the next time you are in school, and we'll be more than happy to take a look. Okay? Have fun with this. Good luck. We'll see you next class.